Welcome students. Today we're going to be talking about right triangle trigonometry. We are still going to do some practice problems from concepts of 4.1 and 4.2 on the homework today, just to keep it fresh in your mind. So while we are learning one section of the book, bear in mind that the rest of the book will still be relevant to the rest of class. So we are going to look at the notes today. In the notes today, we're going to be covering some key concepts. Now, the biblical integration point we're actually going to be covering when we get closer to the application from 4.5. So it will still be here. I just leave it blank until we cover that in class, okay? You guys should know what an hypotenuse, opposite side, and adjacent side is of a right triangle. So if you have a right triangle, which we will talk about in a minute, there is an opposite side of an angle, an adjacent side, and then the hypotenuse. Okay, the rest of this is going to be in the application. So let theta be an acute angle. So these formulas, sine, cosine, tangent, cosecant, secant, cotangent, are actually going to be only defined this way for right triangles, okay? So bear in mind, only for right triangles there's going to be this formula. So let's look at what we will get. So we have a right triangle. Apologies. And theta is right here. This is going to be our hypotenuse. This is going to be our opposite side. And this is going to be our adjacent. Okay? Now, sine. Sine of theta for right triangles is going to be opposite over hypotenuse. Some of you would know TOA. It's useful for, especially, it's useful for SAT when you take it. Okay, so cosine will be adjacent over hypotenuse. Tangent is going to be opposite over adjacent. These are just division, so you divide the lengths. Cotangent is going to be adjacent over opposite. And then cosecant is going to be a hypotenuse over opposite. And secant is going to be hypotenuse over adjacent. Okay, so those are our 6 for right triangles. This is only for right triangles. Okay, now if you notice, if the angle changes, these things will be different, okay? So angle is important, which angle you are doing, okay? So we're going to keep going. So in our unit circle, actually this is a brief tangent. Doo-doo. That was terrible. Okay, this is not a good unit circle, but when you have a point, right, x comma y, and we know the sine and cosine of that point, if you draw the angle, you know that the hypotenuse of this is just 1. So our adjacent is just x, and our opposite is just y. This is our theta. So actually, in a unit circle, really, you're dealing with the same concepts that you're dealing with today. Only, our hypotenuse is always 1 in a unit circle. Okay? Okay. Let's keep going. Okay, exact value. This is in the book, so I'm just going to draw the angle. So, when you have a triangle, I apologies, when you have a triangle, okay, and you have the length of the sides known. If we are to find out the hypotenuse, we use Pythagorean's theorem. Pythagorean's theorem is 3 squared plus 4 squared equals 5 squared. Okay? Okay, so 3 squared plus 4 squared is 25. Sorry, this would be hypotenuse, but 25 equals hyp squared, so hypotenuse equals 5. Okay, what are the 6 trigonometric figures for this? Now remember, you don't need to know the angle to solve this. What you do is you'll get fractions. So exact values will be fraction or square root exact numbers. There's no decimal points for these. Okay, sine of theta. Sine of theta is going to be opposite over hypotenuse, so 4 over 5. Cosine is going to be 3 over 5. Tangent, now is there a process to do this? Yes. This is the process they use, so we'll use it. Apologies. Okay. So they do tangent of theta equals opposite over adjacent. Cosecant is going to just be the opposite of this. So it's going to be 5 over 4. We're just going to erase this stuff because if you haven't gotten it by this point, you can always pause the video and go back. Secant is going to be the opposite of this, so 5 over 3. And reciprocal, it's going to be reciprocal. And cotangent is going to be the reciprocal of this, so 3 over 4. Okay, so notice that once you have sine, cosine, tangent, you can fill the rest, okay? Okay, so that's exact values. What's exact value? It's when we find the square, we find the angle, we find the trig function for specific ones. Okay, there are 2 special triangles that you need to know. 45, 45, 90, and 30, 60, 90. Okay? Okay, these have a few properties. But we can also think of this as another kind of triangle, so pi over 4. So this is pi over 4, pi over 2. And this is pi over 6, pi over 3, pi over 2. Okay? This triangle, the sine of 45 degrees is going to equal the sine of pi over 4, which is going to equal 1 over root 2, which is just when you want to rationalize the denominator, so you have to multiply the bottom by root 2 over 2, and you get sine of 45 degrees equals square root of 2 over 2. Okay, we can also do this for cosine, but I'm just going to simplify it. So cosine of 45 degrees equals cosine of pi over 4 equals root 2 over 2. Okay, same as sine. Now tangent, I'm just going to do tangent, actually, consistency. Tangent of 45 degrees equals tangent of pi over 4 equals, what's this divided by this? It's just the same thing, so it's just going to be 1. Okay, sine, cosine, tangent. So cosecant of 45 degrees is going to equal square root of 2, because it's square root of 2 divided by 1. If you do the triangle, it's right here. curve, but it is. Okay, so this is 45, 45, 90. This is 1, 1, root 2. So root 2 divided by 1 is root 2. Secant of 45 degrees is also root 2. And cotangent of 45 degrees is going to be 1. Okay, so this is the pattern. Know these, memorize them, put them to mind. They're useful. Okay? Now, if you know these two, if you know this special triangle and the other one, you will in fact know every angle on the unit circle. There's one other step you need to know. So, we get 30 degrees. How did they do? Okay, they do 60 degrees on base. It's okay if it doesn't look accurate. It's just a diagram. Okay, so this would be, this is 2, this is 1, this is root 3. Okay, so sine of 60 degrees is going to equal sine of pi over 3 is going to equal, so sine of 60 is 2 over root 3. Oh, sorry, that doesn't make sense. This makes a lot more sense. This is 2, this is root 3. Okay, this is root 3 over 2. Okay, cosine of 60 degrees, or cosine of pi over 3 equals root 3 over 2. Okay, and I'm going to just fill up the tangent and then we'll go to the next video. Sorry, I'll go through this quickly. Okay, so tangent of 60 degrees, tangent of pi over 3 is equal to, sorry, this is 1/2. It's not 3 over 2. 1/2. So this divided by that is going to be root 3. And I'm just going to give you cosecant of 60 degrees. It's going to equal 2 square root 3 over 3. Secant of 60 degrees is going to equal 2. And cotangent of 60 degrees is going to equal square root of 3 over 3. Okay, that's that for now. And then there's 30 degrees. So in class, I will have expected you to figure out what sine of 30, cosine of 30, tangent of 30, cosecant of 30, secant of 30, and cotangent of 30. Okay? Okay, next video.